All right, so this is Unit 8, Lesson 5. And we're going to continue talking about the double angles that we started to talk about in the last lesson. Again, all of these formulas are on your reference sheet. Nice thing is sine 2a only has one option to pick from. Cosine 2a, we got to do a little more, we have a little more decisions to make because there's three different options that we have for cosine 2a. But we'll talk about that more in a minute. Now, in number 1, it says, using the sum identity shown below, derive the identity for sine 2a and the one for cosine 2a. So it says sine of, and this should be an a plus b, is sine a cosine b plus sine b cosine a. Sorry, I had like a brain fart for a second. So if angle A were equal to angle B, then we would end up having, instead of A plus B, it would actually be A plus another angle that's the same value as A, which is sine of 2A. So this is going to help us derive the formula. Instead of an A there, then we're going to have, instead of a B, we're going to have A's here and here, because A is equal to B. So now you would have sine A cosine A plus sine A cosine A. So you end up with sine A cosine A plus another sine A cosine A, which is really 2 sine A cosine A's. So there's how we get this formula here. Now for cosine A plus B, same type of concept. If B is equal to A, we can take this formula, instead of A plus B, we could do B plus B. Take all the A's, make them a B. B plus B would be 2B. Cosine B times cosine B is cosine squared B. Sine B times sine B is sine squared B. And that's this identity here. Now the other two are found by doing some other substitution, these two, but we're not going to get into that right now. Now in number 2, it says verify the identity for sine 2a by using a equals 30 and 2a equals 60. So we want to verify that sine of 2a, which is 2 sine a cosine a, is the same as sine of 2a. We want to verify that that's true. So let's use the angles they gave us. 2 sine 30 cosine 30, and see if that's the same as sine of 2a, which is 60. Sine 30 by now you should be able to do without drawing your triangle is a half. Cosine 30, same thing, you shouldn't have to draw the triangle. Is that equal to sine 60, which is square root of 3 over 2? Well, 2 times a half is 1, and so those end up just canceling to 1. You get 1 times square root of 3 over 2, and square root of 3 over 2 is equal to square root of 3 over 2. So we're good. Moving on to number 3, we're actually getting into some real problems now here. So we have an angle alpha. It's known that that angle is between 90 and 180, which is a fancy way of saying we're in the second quadrant. Cosine alpha is negative 3/5. We want to find sine 2 alpha. So we only have one formula to choose from here. We already know what cosine of alpha is. Problem is we don't know what sine of alpha is. So we're going to have to draw ourselves a picture in the second quadrant. Angle alpha. Cosine, which we were given, is adjacent over hypotenuse. By now you guys should know the 3, 4, 5 right triangle, like the back of your hand. So sine will be opposite over hypotenuse. And because we're in the second quadrant, which is our S quadrant, sine will be positive. So I'm going to take that 2, put it over 1, and that's where you get negative 24 over 25. Now for part B, cosine 2 alpha. Remember from above, we have 3 different formulas that we can use for the cosine double angle. But be smart about the one that you choose. At this point, we just found sine alpha, so we really could use any of the 3. But if the problem gave us the value of cosine alpha, the smartest equation to use would be the one that deals with cosine. So we're going to use the 2 cosine squared minus 1. 2 blank squared minus 1. And in the blank, I know cosine alpha is negative 3/5. Let your calculator help you here. Should be able to do it by hand. Negative 3/5 squared is 9/25. 2 times 9/25 is 18/25. I'm not making a 25 here. 18/25. Number 1 we can rewrite as 25 over 25. So that's where you get negative 7 over 25. But again, don't try to be a hero. Make sure you check your answers on the calculator so you don't make any silly errors. Okay, next page. For the angle A, it's known that angle A is between 180 and 270. So now we're in the third quadrant. Sine of A is negative squared 11 over 6. Find the following. So again, we only have one thing to use here. We already know the value of sine of A. We need to find cosine A. So we need to draw ourselves a picture in the third quadrant. Here's my angle A. We're given sine, which is opposite over hypotenuse. This one's a little trickier. We might actually have to do Pythagorean theorem here to find this missing side. X squared plus square root of 11 squared equals 6 squared. 36 minus 11 is 25. So x ends up being 5. Kind of nice. So now, cosine of that angle, which is adjacent over hypotenuse, is 5 over 6, but we're in the T quadrant where cosine will be negative. So now we have a positive times a negative times a negative. So we know our answer is going to be positive. 2 times 5 is 10 times square root of 11. 6 times 6 is 36. And then 10 and 36 are both divisible by 2. So you get 5 square root of 11 over 18. Okay. Similarly for cosine 2a, this time the only thing given to us is sine. So I would probably choose to use the formula that only deals with sine, because I know this is correct. I'm not positive that what I found for cosine, well, I know that I'm correct, but if you were taking the Regents, you wouldn't be sure if you definitely found cosine A correctly or not. So go with what's given to you. 1 minus 2 sine squared, and I know sine is negative square root of 11 over 6. You could use your calculator to do this, but square root of 11 times square root of 11 is 11. 6 times 6 is 36. 2 times that will be 22 over 36. And the number 1 is 36 over 36. Minus 22 over 36, which is 14 over 36. They're both divisible by 2, so we get 7 over 18. Again, make sure you're at least checking your answers on the calculator so that you don't make any silly mistakes. All right, I need to erase this so I can see this problem. Which of the following is equivalent to 2 sine 50 cosine 50? Well, to me, this looks exactly like sine 2a, right? 2 sine a cosine a. So this is the same exact formula for sine of 2a. In this case, our a is just 50. So we get sine of 100, choice 2. But again, don't ever get this question wrong. You could always plug that in the calculator, plug all 4 choices in the calculator. The only one that'll match will be choice 2. Okay. Similar for number 6, which is not equal to cosine 80. Now, cosine 80 could be cosine of 2 times 40, which would be cosine squared 40 minus sine squared 40. That could be 1. 2 cosine squared 160. Wait, that should say 2 cosine squared 40 minus 1. So that one is not equivalent. Okay. This one, we're given cosine A. So let's use the formula that deals with cosine. 2 blank squared minus 1. Plug in what they gave us for cosine alpha, which is 0.28. Use your calculator. Choice 4. And the last one, find the value of cosine 130. Again, 130 could be double 65. And if we're doing cosine 2a, that could be 2 cosine squared a minus 1. Well, 2 cosine squared of 260, I don't know where that came from. 2 cosine 65, well, we would need cosine squared 65 minus 1 to make that work. 1 minus 2 sine squared a, that one seems good. This one, the 130, shouldn't be there. But again, there's no reason to get a multiple choice like this wrong. Plug this in, plug all 4 choices in. The only one that does give you the same value is choice 2. So make sure you're being smart about doing the multiple choice questions on the day of your Regents. Okay? But the nice thing is, these formulas are on your reference sheet. You just have to know how and when to use them. Okay, so that was your second day of your trig identities.